Hello, in this lecture we find out the ratio between the two radii of the circles. In the drawing we have a big circle. Inside this big circle we have two smaller circles. The radius of this circle is B, the radius of this circle is A, and our mission is to find out the ratio of B over A. In addition, we know that the right triangle ABC, in this angle ABC equals to 90 degrees. The right triangle ABC is partially blocked by the biggest circle. Side AB equals to 5 units in its length, side BC equals to 12 units in its length, and we also know that AN equals to NC. Our mission is to find out the ratio of B over A, that is the ratio between the radius of this circle to that is B over the radius of this circle that is A. So first of all, we'll implement the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, in the right triangle ABC, the square of the hypotenuse must be equal to the sum of the squares of the perpendiculars. That is to say, AC square equals to AB square plus BC square. AC square equals to AB square plus BC square. Now repeat again. In the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square equals to AB square. AB equals to 5 units in its length. Therefore AB square is 5 square, this is 25, plus BC square. According to what is given as the equation, BC equals to 12 units in its length. Therefore BC is 12 square, that is 144. If we put in formula, that AC square equals to 25 plus 144 is 169. AC square equals to 169. Here we take the root of this equation and finally we get that AC equals to the square root of 169, that is 13. That is to say, the length of the hypotenuse AC of the right triangle ABC equals to 13 units. AC equals to 13, and because of the fact that AN equals to NC, it means that at point N, the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. So you can write down that AC over 2, that is actually 13 over 2, is equals to AN, that is the first half of the hypotenuse, and it is also equal to NC, that is the second half of the hypotenuse NC. So AN equals to NC. Or in other words, NC equals to AN, that is equal to 13 over 2. So each half equals to 13 over 2. AN equals to 13 over 2, and NC, the second half of the hypotenuse AC, is also equals to 13 over 2 units in its length. Okay. So in the next step I will present to you rule number 8 and we'll implement rule number 8 in our drawing. According to rule number 8, according to rule number 8, the radius of a circle that is blocked by a right triangle is equal to R equals to A plus B minus C over 2. So in the drawing we have a right triangle ABC, this angle ABC equals to 90 degrees. The length of side AB of triangle ABC equals to A units in its length. Side BC equals to B units in its length, and the hypotenuse AC, the length of the hypotenuse AC of the right triangle ABC equals to C units in its length. The right triangle ABC blocks this circle, the radius of this circle is R. And according to this rule number 8, we can calculate the value of R only by knowing the side lengths of the right triangle that blocks this circle. That is to say, the radius R of this circle that is blocked by the right triangle ABC, R will be equal to A plus B minus C over 2. So we can implement rule number 8 in our drawing. In our drawing, we have the right triangle ABC that blocks this circle, and the radius of this circle is A. According to rule number 8, the value of A will be equal to AB plus BC minus AC over 2. Repeat again. According to rule number 8, in our drawing, the value of A will be equal to AB plus BC minus AC over 2. So A will be equal to AB is 5, plus BC is 12, and we just like that found out that AC equals to 13. It is minus 13 over 2. 5 plus 13 is 17, minus 13 over 2. 17 minus 13 is 4, and 4 over 2 is 2. So finally we found out that the radius A, the length of the radius A of the smaller circle is equals to 2 units. A equals to 2. A, the length of the hypotenuse, the length of the radius of this circle is A, so the value of A is 2. In the next step we will define the center of this circle as P. We will define the center of this circle as Q. And finally we will define the center of the bigger circle. Here this point is O. We will define the point of tendency of tangent AB with this circle as T. We join points P and T together by a straight line. point P is the center of this circle, point T is the point of the circle itself. Therefore PT is the radius of this circle, that is equals to A, and A equals to 2. So the radius PT of this circle is drawn to point T, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. Angle ABC equals to 90 degrees because triangle ABC is a right triangle. We will define the point of tendency of tangent BC with this circle as N. The next step, we join points P and N together by a straight line. Pn is the radius of this circle, is equal to N, A equals to 2. So Pn equals to 2. And the radius Pn of this circle is drawn to point N, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent Bn will be perpendicular to the radius Np. Bn tangent BC will be perpendicular to the radius Np. If BC is perpendicular to Np, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, so actually inside quadrilateral PTBN we have 1, 2 free right angles. The sum of free right angles is 90 times 4 is 270 degrees, plus the size of this fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles in quadrilateral PBN to 360 degrees, the missing angle here must be equal to 90 degrees. So I can find out that inside quadrilateral TPBN we have 1, 2, 3, 4 right angles. And any quadrilateral that has 4 right angles must be at least a right angle, if not a square. So we relate to quadrilateral TPBN as a right angle, and we know that the opposite sides of a right angle are equal to each other. That is to say, TP equals to Bn. But TP is 2, therefore Bn must be also equal to 2. Likewise, in right angle TPBN, Pn must be equal to Tb. But Pn is 2, therefore Tb must be also equal to 2. So it is given us in the question that the length of PA is 5, the length of BT is 2, therefore BA minus BT is TA. Again, BA minus BT is TA. BA is 5, BT is 2, and 5 minus 2 is 3. So 80, or PA equals to 3 units in its length. And here we also have rule number 2 that says that the lengths of two tangents from common external point to a circle are equal. We have the common external point A. From the common external point A, we have two tangents to the circle, tangent AT and tangent AN. According to rule number 2, they are equal to each other. That is to say, AT equals to AT equals to AM. Okay? The two tangents are AT and AM from point A. Therefore, AT equals to AM, but AT is 3, therefore AM must be also equal to 3. So we found out that AM equals to 3. We have already found out that AN equals to 13 over 2. So AN minus AM equals to MN. Again, AN minus AM equals to MN. So write it down. equals to mn. AN is 13 over 2 minus AM is 3 plus equal to mn. So here we multiply minus 3 by 2 and then we divide it by 2 in order to have a common factor with 13 over 2, and we get that 13 over 2 minus 3 times minus 2 is minus 6 is equals to mn. 13 minus 6 is 7, so in total this expression equals to 7 over 2, and this is equals to mn. So in conclusion, we found out that mn, the length of this line segment mn, is equals to 7 over 2 units. In the next step, I will present to you the new rule number 7, and we will implement rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of if a line segment that is drawn from the center of a circle bisects the chord, then the line segment is also perpendicular to the chord. The center of this circle is 0.0. We have line segment OM that bisects chord AB. That is to say, AM equals to MB. So according to this rule number 7, whenever you have from the center of a circle a line segment that bisects the chord, like here, line segment OM bisects chord AB in the sense that AM equals to MB, then line segment OM will be also perpendicular to AB. If OM is perpendicular to AB, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. Again, whenever you have a line segment from the center of a circle like here, from point O that bisects the chord, like here OM that bisects chord AB, if OM bisects chord AB, then OM will be also perpendicular to AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. We can implement rule number 7 in our drawing. Because in our drawing, according to our definition, point O is the center of the biggest circle. We join points O and N together by a straight line. Line segment ON starts from the center of the biggest circle and ends at point N. Line segment ON from the line segment from the center of the biggest circle, that is to say from point O, bisect chord AC, that is to say AN equals to NC. Again, line segment ON bisect chord AC because AN equals to NC. And therefore, according to rule number 7, whenever you have a line segment from the center of the circle that bisects the chord, then line segment ON will be also perpendicular to AC. If ON is perpendicular to AC, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. This is according to rule number 7. So can I know that according to rule number 7, line segment ON is perpendicular to chord AC. According to rule number 7, line segment ON that is drawn from the center of the biggest circle, that is to say from point O, is perpendicular to chord AC. In addition, point Q is the center of this circle. Point N is the point of the circle itself, therefore Qn is the radius of this circle. The radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, like here, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So we can write down also that the radius QN is also perpendicular to AC. The radius QN is also perpendicular to AC, and from those two statements that ON is perpendicular to AC and QN is also perpendicular to AC, we derive that point O lies on the radius QN. Look it again. This is point O, that is the center of the biggest circle. This point O must lie on the radius QN of this circle. Why? Because line segment ON creates 90 degrees with AC at point N. But line segment and the radius QN also creates 90 degrees with AC at point N. Therefore, point O must lie on QN. Otherwise, if point O lies here, at this point it doesn't lie on the radius QN, then this angle will never create 90 degrees with AC. And this side, the angle is less than 90 degrees, and the other side, at point N, this angle is greater than 90 degrees. Okay? So, in order to line segment ON will create 90 degrees with AC, point O must lie on QN. Otherwise, point O and N ON will never create line segment ON if it is here. Line segment ON will never create 90 degrees with AC. Okay? So if point O lies on QN, means that all the 3 points Q, O, N, the line on the straight line, or Q, O, N is one straight line. Okay, Q, O, N is one straight line. So we can write down that Q, O, N is one straight line. Because QN is a radius, it is absolutely a straight line, and point U lies on the straight line QN, therefore in total QN must be a straight line. QN is a straight line. Again, QN is the radius of this circle, therefore it is absolutely a straight line. but point O also lies on the straight line QN, so in total QON is one straight line. Okay, QON is one straight line. Likewise, we will define the point of tendency of this circle with the biggest circle as U. As we will draw tangent PW will be tangent to both circles, to this circle and to the biggest circle, point U. This is tangent PW, that is tangent at point Q to both circles, to the biggest circle and to this circle. So here we have point Q is the center of this circle. Point U is the point of this circle itself, therefore QU is the radius of this circle, is equal to units in itself. The radius QU is 1 to point Q, that is the point of tendency of tangent PW with this circle. And whenever you have a radius that is 1 to the point of tendency, then tangent PW will be perpendicular to the radius UQ, or PW is perpendicular to QU. So you can write here that QU is perpendicular to VW, the radius QU is perpendicular to tangent VW, likewise point O, this point is the center of the biggest circle, point U is the point of the biggest circle itself, therefore OU is the radius of the biggest circle that we defined as X. The radius OU is 1 to point U, that is the point of tendency of tangent VW with the biggest circle. And whenever you have a radius that is 1 to the point of tendency, then tangent VW will be perpendicular to the radius UO. Again, VW is perpendicular to UO. So you can write here that OU, the radius OU is also perpendicular to tangent VW. The radius OU is also perpendicular to tangent VW. So, and from those two statements, QU is perpendicular to VW and OU is perpendicular to VW, we will derive that those 3 points O, Q and U, they are all located on the same straight line, or OQU is one straight line. OQU, line segment OQU is one straight line. So why line segment OQU is one straight line? Why? Because OU, the radius OU is tangent to VW at point U. But we also know that QU, the radius QU of this circle is also tangent to VW at point U. So if one of those 3 points OQ and U will not be located on this straight line, then it will never create angle of 90 degrees with VW. For example, if point Q is located here, then QU will not be perpendicular to VW. Or if point O is located here, then OU will not be perpendicular to VW. So all the 3 points OQ and U must be located on one straight line, therefore OQU is one straight line. So in conclusion, we know that QON is one straight line and OQU is one straight line. QON is one straight line. So QON contains the 2 points Q and O, and it is one straight line according to what we already found out. And we just right now found out that OQU is also one straight line. OQU is one straight line. So we have the straight line OQ is common to both line segments. The straight line OQ is common to the straight line QON, and it also belongs to the straight line OQU. Okay? And we know that 2 points determines one straight line. So if OQON is one straight line, and it contains the straight line QO. But from the other side, we also found out that OQU is also one straight line, and it also contains the straight line OQ. So this straight line OQ belongs to both QON and also OQU. And therefore, because of the fact that the straight line OQ determines one specific straight line and it belongs to both line segments, we can say that in total that OQU belongs to both line segments. It means that it is one straight line. Why? Because from point OQ, the 2 points O and Q determines one straight line. So OQN is one straight line, therefore OQ is one straight line. But we also found out that OQU is one straight line. That is to say, here OQ is one straight line. So in both line segments QON and OQU, we have the 2 points OQ. And the 2 points OQ determines one straight line. Therefore, those two line segments, the one straight line that contains the 2 points OQ. Okay. Those two line segments QON contains the straight line QO, and the line segment OQU also contains the same straight line QO. Therefore, both line segments, the one straight line QOQ. Okay. So in total, you can say that the two line segments QON and OQO is one straight line OQ. Okay, so OQ is the straight line, that the two line segments QON and OQU contain, and therefore it is actually one straight line. Okay. From the line segment QON, we have the straight line QO. From the line segment OQU, we have the same straight line QO. Therefore, in total, QO belongs to both line segments. Therefore, it is one straight line. Both two line segments, it is one straight line that contains the straight line QO. Okay. And because of the fact that it is one straight line, therefore all the 4 points N, O, Q, and U, they are all located on the same big straight line. So if N, O, Q, U is one straight line, then N, Q, U is also one straight line, and therefore NU is also one straight line. But NU is a straight line that contains the points N and U of the circle itself, and therefore NU is a chord that passes through point Q, that is the center of this circle, and any chord that passes through the center of the circle must be the diameter of the circle. Therefore, NU or UN is the diameter of this circle. UN is the diameter of the circle. And we know that the diameter of one circle is twice as long as the radius, and the radius of this circle is b, therefore the diameter UN must be equal to 2b. And UN equals to 2b. Repeat again on the explanation why actually we are talking in one big straight line. In line segment QON, that is a straight line, we have QO that determines one straight line. But and in the other line segment OQU, that is also one straight line, we have the same line segment QO that is also a straight line. So in both line segments we have the same straight line QO, therefore it is one straight line. QO is one straight line with the 2 points Q and O. The 2 points Q and O determines only one and one straight line. Therefore, because of the fact that QO belongs to both line segment QON and OQO, it means that we have here one straight line that is determined by the points Q and O. Okay, so found out that UN equals to 2b. In the next step, I present to you rule number 9, and we will join points O and P together by straight line. Point O is the center of the bigger circle. Point P is the center of the smaller circle. And the straight line OP connects the centers of the bigger circle with the smaller circle. And this smaller circle touches the bigger circle at this point. We define the touching point as point S. That is to say, the smaller circle touches the bigger circle at point S. So here we have rule number 9. According to rule number 9, if two chords touch each other internally, then the straight line that connects their centers together must pass through their touching point. The center of the big circle is here at point O, the center of the small circle is here at point M, and the straight line that connects their centers together is the straight line OM. According to this rule number 9, the straight line OM passes for point P. That is to say, OMP is one straight line. OMP is one straight line. So we can implement rule number 9 in our drawing. Again, the straight line that connects the center of the bigger circle with the center of the smaller circle is the straight line OP. According to this rule number 9, the straight line OP must pass through their touching point, that is to say for point S. So OPS is one straight line. So we can write down that OPS is one straight line. according to rule number 9, line segment OPS is one straight line. So if OPS is one straight line, it means that SO is also a straight line, and SO minus SP equals to PO. Again, SO minus SP equals to PO. So we can write down that SO minus SP equals to PO. So what is the definition of the straight line SO? Line segment SO starts from point O, it is the center of the bigger circle, and ends at point S, that is the point of the bigger circle itself. So this is exactly the definition of a radius. So SO is the radius of the bigger circle, is equal to X. So I can solve SO by X minus SP. So over the definition of line segment SP, it starts from point P, that is the center of this circle, and ends at point S, that is the point of this circle itself. So PS is the radius of this circle, that is equal to 2. So I start with PS by 2. So we found out that PO equals to X minus 2. So this line segment PO equals to X minus 2 units in its length. Okay. In the next step, we will extend the perpendicular ON by straight line. ON is a perpendicular, it is absolutely a straight line, and we extended it by straight line. Therefore the result, this is the result, it must be also a straight line. So if we focus on this side, on this straight line, it's point N. Here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have this side of the straight line is point N, we have this angle that is equal to 90 degrees, plus the missing angle total must be equal to 180 degrees, therefore the missing angle must be equal to 90 degrees. So AC is tended to this circle at point M. We join points P and M together by straight line. Point P is the center of this circle, point M is the point of the circle itself, therefore PM is the radius of this circle that is equal to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. In the next step, we will go perpendicular on the radius MP, it's point P. Again, we will go perpendicular on the radius MP, it's point P. So this angle equals to 90 degrees according to our construction. We'll extend the perpendicular until it touches the extended ON, and we define the touching point as point T. So inside quadrilateral MNTP we have 1, 2, 3 right angles, therefore this fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral MNTP we have 1, 2, 3 angles. So in quadrilateral MNTP we have 4 right angles. Therefore we relate to quadrilateral MNTP is a rectangle. We know that the opposite sides of the rectangle are equal to each other. That is to say, MP equals to NT, but MP is 2, therefore NT must be also equal to 2. Likewise in rectangle MNPT, MN equals to PT. MN must be equal to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. The next step we find the length of line segment ON as H, and we'll implement the Pythagoras theorem on the right triangle POT. So I copy the right triangle POT in the page and we'll implement on it the Pythagoras theorem. So actually, this is the right triangle OPT, that the copy from the original drawing. We have already found out that the hypotenuse PO equals to x minus 2 units in its length. We just had now found out that PT equals to 7 over 2. And what is the length of OT? The length of side OT. OT equals to ON plus NT. So OT equals to ON, that is H, plus NT, that is 2. So in total OT equals to H plus 2. OT equals to H plus 2. Now we will implement on this right triangle OPT the Pythagoras theorem. According to the Pythagoras theorem in the right triangle OPT, PO square equals to OT square plus PT square. Again, PO square equals to OT square plus PT square. PO is x minus 2, therefore PO square is x minus 2 square. And it is equals to OT square. OT is h plus 2, therefore OT square is h plus 2 square. Plus PT square. PT is 7 over 2, therefore PT square is 7 over 2 square, that is 49 over 4. Here we open the brackets on both sides of the equation and we will get that x minus 2 square equals to x square plus 2 square, that is 4, minus 4x, and it equals to h plus 2 square. H plus 2 square equals to h square plus 2 square, that is 4, plus 4h plus 49 over 4. So I copy the equation in a new page here. Found out that x square plus 4 minus 4x equals to h squared plus 4 plus 4h plus 49 over 4. So copy this equation here to this new page. In the next step, we join points O and C together by straight line. What is the definition of the straight line OC? Line segment OC starts from point O, that is the center of the bigger circle, and then at point S, that is the point on the bigger circle itself. Therefore, OC is the radius of the bigger circle, that is equal to x. ON equals to h according to our definition, and we already found out in the beginning of the lecture that NC equals to 13 over 2. So I copy the right diagonal when C in a new page, and we will implement on this right diagonal when C the Pythagoras theorem. Repeat again, the north of the hypotenuse OC is x, y equals to h, also according to our definition. In the beginning of the lecture, we found out that NC equals to 13 over 2. Now we implement on this right diagonal, we see the Pythagoras theorem. According to the Pythagoras theorem, OC squared, the right diagonal in C, OC squared equals to ON squared plus NC squared. So OC is x, therefore OC squared is x squared, and it equals to ON squared. ON is h, therefore ON squared is h squared plus NC squared. NC is 13 over 2, therefore NC squared is 13 over 2 squared. It is 169 over 4. So in conclusion, we found out that x squared equals to h squared plus 169 over 4. Now we can substitute x squared in this equation by h squared plus 169 over 4. We'll do it now and we get it. So x squared is h squared plus 169 over 4 plus 4 minus 4x is equals to h squared plus 4 plus 4h minus 49 over 4. Actually, plus 49 over 4. So here we have h squared on both sides of the equation. So h squared will get cancelled. We also have 4 on both sides of the equation, so 4 also will get cancelled. In this side of the equation we left only 169 over 4 minus 4x, that equals to 4h plus 49 over 4. Here we subtract 49 over 4 from this equation and we get that 169 minus 49 over 4 minus 4x equals to 4h. Here we add 4x to this equation, and finally we get that 169 minus 49 is 120, so in total this expression equals to 120 over 4. This equals to 4x plus 4h. Here we take 4 as a grand factor from those two expressions, so inside the brackets we left only with x plus h. 120 over 4 is 30, so in total we found out that 30 equals to 4 times x plus h. We divide this equation by 2 and get that 30 over 2 is 15, equals to 4 over 2 is 2. 15 equals to 2 times x plus h. Here we divide this equation by 2, and finally we get that x plus h equals to 15 over 2. X plus h equals to 15 over 2. Repeat again, we found out that x plus h equals to 15 over 2. So what is the length of line segment UN? The length of line segment UN equals to UO. It is the radius of the biggest circle that is equals to x plus ON, that is h. So in total we found out that UN equals to x plus h. UN equals to x plus h. From one side, but from the other side we already found out that UN, which is the hypotenuse of this circle, that is to say we already found out that UN equals to 2b. So can I get that UN equals to 2b on the other side? And from those two equations, UN equals to x plus h and UN equals to 2b, we derive that x plus h equals to 2b. Okay? But we found out that x plus h is also equals to 15 over 2, so we can write here that x plus h equals to 15 over 2. And for this equation, 15 over 2 equals to x plus h equals to 2b. We conclude that 15 over 2 equals to 2b. Here we divide this equation by 2 and finally we get that b equals to 15 over 2 over 2 is 15 over 4. So finally we found out that the length of this the radius of this circle b, it is equals to 15 over 4 in its length, and we already found out that the radius of this circle a, it is equals to 2 units, a equals to 2, and the ratio b over a will be equal to b, that is 15 over 4 over a, that is 2. So b over a equals to 15 over 4 over 2, that is 15 over 8. So in conclusion, we found out that the ratio b over a equals to either 15 over 8. In terms of numbers, it is equals to 1.875. I repeat again. The ratio between the radii of those two circles is b over 8 is equals to either 15 over 8, or in terms of numbers, it is equals to 1.875. In the next step, I'll summarize the lecture. In this lecture, we found out the ratio between the radius of this circle and the radius of this circle, that is to say, the ratio of b over a. So in the drawing, we have the biggest semicircle. Inside this biggest semicircle, we have two small circles. The radius of this circle is b and the radius of this circle is a. Our mission is to find out the ratio of b over a. In addition, you know that the biggest circle contains partially the right triangle ABC. This angle ABC equals to 90 degrees. The length of side AB is 5 units, side BC equals to 12 units in its length. And you also know that AN equals to NC. Our mission again is to find out the ratio of B over A. So first of all, we implemented the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem on the right triangle ABC, AC squared equals to AB squared plus BC squared. Repeat again, the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So for we found out that AC squared equals to 25 plus 144, which is 169. So AC squared equals to 169. Here we took out all of this equation, and found out that AC equals to the square root of 169, it is 13. So the length of the hypotenuse of this right angle ABC, the length of the hypotenuse AC equals to 13 units in itself. And because of the fact that at point N, the hypotenuse AC is bisected into two halves, the first half is AN and the second half is NC. So AC over 2 is 13 over 2. Again, the first half is AN and the second half of the hypotenuse AC is NC. So from this equation we can derive that NC equals to AN equals to 13 over 2. Each half equals to 13 over 2. Yeah, the second half NC equals to 13 over 2. The next step I presented to you rule number 8 and implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to R equals to A plus B minus C over 2. We have here a right triangle ABC, this angle ABC equals to 90 degrees. The length of side AB is A, the length of side BC is B, the length of the hypotenuse AC is C. So the right triangle ABC blocks this circle and the radius of this circle is R. According to rule number 8, we can calculate the value of R only by knowing the side lengths of the right triangle that blocks the circle. That is to say, the radius R will be equal to A plus B minus C over 2. We can implement rule number 8 in our drawing. Why? Because in our drawing we have the right triangle ABC that blocks this circle. The radius of this circle is A. According to rule number 8, the radius of this circle that is blocked by the right triangle ABC will be equal to AB plus BC minus AC over 2. Repeat again. The value of A will be equal to AB plus BC minus AC over 2. AB is 5, BC is 12, and AC is 13. So in total equals to 5 plus 12, that is 17 minus 13 over 2. 17 minus 13 is 4, and 4 over 2 is 2. So found out that the length of the radius of this circle A is equals to 2 units. Okay. In the next step, we define the center of this circle as P, we define the center of this circle as Q, and we define the center of the biggest circle as O. We define the point of tendency of tangent AB with this circle as T. We join points T and P together by straight line. Point P is the center of the circle, point T is the point of the circle itself, therefore PT is the radius of the circle that is equal to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle, and whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we define the point of tendency of tangent BC with this circle N. We join points P and N together by straight line. Pn is the radius of this circle, that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle, and therefore tangent BC will be perpendicular to the radius NP. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So inside quadrangle PTBN we have 1, 2 right angles, therefore the fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So inside quadrangle PTBN we have 4 right angles. Any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrangle PTBN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, Pn equals to GB but Pn is 2, therefore Tb must be also equal to 2. Likewise, in right angle TPBN, Tp equals to Bn, but Tp is 2, therefore Bn must be also equal to 2. So we know that AB equals to 5, or BA equals to 5, BT equals to 2, therefore BA minus BT equals to 80. Again, BA minus BT equals to 80. So BA is 5 and BT is 2, and 5 minus 2 is 3. So PA equals to 3. Then we have rule number 2. According to rule number 2, the lengths of two tangents from the common standpoint to a circle are equal. We have the common standpoint point A. From the common standpoint point A, we have two tangents to this circle, tangent AT and tangent AM. According to rule number 2, they are equal to each other. That is to say, AT equals to AM, but AT is 3, therefore AM must be also equal to 3. This line segment AM equals to 3 units. We have already found out that AN equals to 13 over 2. AM is 3, therefore AN minus AM equals to MN. Again, I repeat again that AN minus AM equals to MN. AN is 13 over 2, AM is 3, so it is 13 over 2 minus 3, that is equal to MN. Here we multiplied minus 3 by 2 and then we divided by 2 in order to have a common factor with 13 over 2. We found out that 13 over 2 minus 2 times 3 is minus 6. So this expression total equals to 13 minus 6 over 2. 13 minus 6 is 7. So in total this expression equals to 7 over 2. That is to say Mn, the length of this line segment Mn is equal to 7 over 2 units. Then I presented to you rule number 7 and we implemented rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisects the chord, then the line segment must be also perpendicular to the chord. Point O is the center of this circle. Line segment OM bisects chord AB. That is to say AM equals to MB. So whenever we have a line segment from the center of a circle that bisects the chord, like in this drawing, line segment OM is from the center of the circle, that is to say from point O, and it bisects chord AB. That is to say AM equals to MB. Then OM must be also perpendicular to AB. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees according to this rule number 7. We can implement rule number 7 in our drawing. Why? Because in our drawing, point O is the center of the biggest circle. We join points O and N together by side line. Line segment ON is from the center of the biggest circle, that is to say from point O, and line segment ON bisects chord AC. Why? Because AN equals to NC, and therefore whenever line segment from the center of the circle that bisects the chord, the line segment must be also perpendicular to the chord. That is to say ON is perpendicular to chord AC. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule number 7. So we can write down here that according to rule number 7, line segment ON is perpendicular to chord AC. In addition, we know that point O and point Q is the center of this circle, point N is the point of the circle itself, therefore Qn is the radius of this circle that is equal to B units in itself. The radius Qn is 1 to point N, that is the point of tendency of tangent AC with this circle, and therefore tangent AC will be perpendicular to Qn. Okay, AC is perpendicular to Qn. Or Qn is perpendicular to AC, it is the same. So we can write here that the radius Qn is also perpendicular to AC. Line segment ON is perpendicular to AC. From those two statements, we derive that point O lies on the radius QN. This point O must lie on the radius QN in order that ON will be perpendicular to AC. Otherwise, if point O doesn't lie on QN, then ON will not be not perpendicular to chord AC. Therefore, point O must lie on QN in order that ON will be perpendicular to AC. Repeat again that point O must lie on the radius QN. If point O lies on QN, it means that QON is one straight line. Point O lies on the radius QN, therefore QON is one straight line. QON is one straight line. Likewise, here we find the touching point between the circle and the biggest circle is point U. We have tangent VW that is tangent to both circles at point U. Okay. And then point Q is the center of the circle, point U is the point of the circle itself, therefore QU is the radius of the circle. The radius QU is drawn to point U, that is the point of tendency of tangent VW with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UQ. Or QU is perpendicular to tangent VW. That is from one side, but from the other side, point O is the center of the bigger circle. Point U is the point of the bigger circle itself. So this is exactly the definition of a radius. That is to say, OU is the radius of the bigger circle. The radius OU is drawn to point U, that is the point of tendency of tangent VW with the bigger circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. So VW is also perpendicular to the radius OU. Or OU is perpendicular to VW. So we already found out that the radius QU is perpendicular to tangent VW, and the radius of the biggest circle OU is also perpendicular to tangent VW. From those two statements, we will derive that in total OQU, all the 3 points lie on the same straight line, or OQU is one straight line. Okay, OQU is one straight line. Okay, so, and we have the rule that 2 points determine one specific straight line. Okay? And according to what we have already found out, that QON is one straight line. So those 2 points Q and O determine one straight line. But we just right now found out that OQU is one straight line. OQU is one straight line. So in the straight line OQ, we have those 2 points. So the same 2 points OQ determine the same straight line. OQ must be also determine the same straight line. So in both line segment QN and OQU, they are both determining the same straight line OQ. Therefore, we can say that all the 4 points N, OQ, and U lie on the same straight line that is determined by OQ. Okay? Therefore, all those 4 points O, N, O, Q, and U must lie on one straight line, and the straight line is determined by the 2 points O and Q. Okay? Therefore, NOQU is one straight line. If NOQU is one straight line, it means that NQU is also one straight line. And if NQU is one straight line, it means that NU is also one straight line. But NU is a straight line that touches the circle point U and N. Therefore, it is a chord. NU is a chord that passes for point Q, that is the center of this circle, any chord that passes through the center of the circle must be the diameter of the circle. Therefore, UN that passes through point Q is the diameter of the circle. As we know that the diameter of any circle is twice as long as the radius, and the radius is B, so UN, the diameter, must be equal to 2B. Okay. UN equals to 2B. Again, UN is the diameter of the circle, and UN equals to 2B. Okay. So, in the next step, I actually presented to you on number 9 and implemented on number 9 and number 1. But first of all, we join points O and P together by a set line. Point O is the center of the bigger circle. Point P is the point of the point O is the center of the bigger circle. Point P is the center of the smaller circle. Again, the set line OP joins the two centers together. At point S, the small circle touches the bigger circle. So they have internal arch between them at point S, and OP is the set line that connects their centers together. According to rule number 9, if two circles touch each other internally, then the set line that connects their centers together must pass for their touching points. Point O is the center of the big circle, point M is the center of the small circle. The set line that connects the centers together is the set line OM. And according to this rule number 9, the set line OM must pass for point P, or OMP is one set line. OMP is one set line. So point O is the center of the bigger circle, point P is the center of the smaller circle, and the set line that connects their centers together is OP. The set line OP, according to rule number 9, must pass for point S, or OPS is one set line. Why? Because they have an internal arch between them at point S. That is to say, they are touching each other internally at point S. Therefore, we can implement it, rule number 9, that is to say, according to rule number 9, OPS is one set line. So we can write down here that OPS is one set line. If OPS is one set line, it means that OS is also a straight line, and OS minus PS is PO. Again, OS minus PS is PO. Again, OS or SO minus SP equals to PO. What is the definition of the straight line SO? It starts from point O, and that is the center of the bigger circle, and that's at point S, that is the point of the bigger circle itself. Therefore, OS is the radius of the bigger circle, that is equal to x. So we can substitute OS or SO by x. What is the definition of line segment PS? Line segment PS starts from point P, that is the center of the small circle, and that's at point S, that is the point of the small circle itself. Therefore, PS is the radius of the small circle, that is equal to 2. Therefore, we can substitute PS by 2. And SP is 2. So in conclusion, we found out that PO equals to x minus 2. PO equals to x. This line segment PO equals to x minus 2 units in its length. Then we extended perpendicular OM by a straight line, and we focused. So therefore, in total, when you extend the straight line by a straight line, we get a straight line. Therefore, OT is the straight line. If you focus on this side of the straight line OT at point N, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at this side of the straight line OT at point N? We have this angle that is equal to 90 degrees plus the missing angle. In total, it must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. We have AC extended to this circle point M. Point M is the point of tendency. We join points P and M together by straight line. PM is the radius of this circle. The radius PM is drawn from point M. Therefore, AC will be perpendicular to the radius MP. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. The next step, we did the construction. We drew perpendicular on the radius MP at point P. Again, we do perpendicular on the radius MP at point P. So this angle equals to 90 degrees according to our construction. Then we extended the perpendicular until it touches the extended ON at point T. This way we created quadrilateral MNPT. Inside quadrilateral MNPT we have 1, 2, 3 right angles. Therefore the fourth angle here must be equal to 90 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral MNPT we have 4 right angles. Therefore we will relate to quadrilateral MNPT as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say MP equals to NT, but MP is 2, therefore NT must be also equal to 2. Likewise, in rectangle MNPT, MN must be equal to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. We define the length of line segment ON as H, and then we implemented the Pythagoras theorem on the right green triangle of PT. So I copied the right green triangle of PT in the new page and implemented on it the Pythagoras theorem. PO is x minus 2, PT is 7 over 2. And again, PO, the opposite PO equals to x minus 2. We just write down found out that PT equals to 7 over 2, and what is the length of OT? OT equals to ON plus NT, that is to say OT equals to ON, that is H, plus NT, that is 2, so in total OT equals to H plus 2. OT equals to H plus 2, the opposite OP is x minus 2, and PT is 7 over 2, so according to the Pythagoras theorem, on this right triangle of PT, we get that OP square equals to OT square plus PT square. PO square equals to OT square plus PT square. PO is x minus 2, therefore PO square is this x minus 2 square. That equals to TO square. TO is h plus 2, therefore TO square is h plus 2 square plus PT square. PT is 7 over 2, therefore PT square is 7 over 2 square, that is 49 over 4. So in conclusion, we found out that x minus 2 square equals to h plus 2 square plus 49 over 4. We open the brackets on both sides of the equation and found out that x minus 2 square equals to x square plus 4 minus 4x. And it is equals to h plus 2 square is h square plus 2 square, that is 4 plus 4h plus 49 over 4. Then I copy this equation here in the new page. So this is the equation that I copied from the previous page. Then we join points O and C together by straight line. Point O is the center of the biggest circle, point C is the point of the biggest circle itself. Therefore OC is the radius of the biggest circle, that is equal to x. ON equals to h, then NC equals to 13 over 2 according to what we have already found out in the beginning of the lecture. So I copied the right triangle ONC in the new page. And we created here by Pythagoras theorem. Again, the opposite OC is x. ON equals to h according to the definition. At the beginning of the lecture, I found out that NC equals to 13 over 2. So in this right triangle ONC, OC square equals to ON square plus NC square. Again, OC square equals to ON square plus NC square. OC is x, therefore OC square is x square. And it is equal to ON square. ON is h, therefore ON square is h square plus MC square. MC is 13 over 2, therefore MC square is 13 over 2 squared, that is 169 over 4. So in conclusion, we found out that x squared equals to h squared plus 169 over 4. So we can substitute x squared here by h squared plus 169 over 4. We did it. And we got that here x squared is h squared plus 169 over 4 plus 4 minus 4x, that is equal to x squared plus 4 plus 4h plus 49 over 4. So here we have h squared on both sides of the equation. So h squared will get cancelled. So here we have also 4 on both sides of the equation. So 4 also will get cancelled. So in this side of the equation we left only 469 over 4 minus 4x. In the other side of the equation we have it is equals to 4h plus 49 over 4. We subtracted 49 over 4 from this equation, so now that 169 minus 49 over 4 minus 4x equals to 4h. 169 minus 49 is 120, so in total this expression equals to 120 over 4. That is equal to 4x plus 4h. Here we took 4 as a ground factor from those two expressions, so inside the brackets we left only x plus h. 120 over 4 is 30, so in conclusion found out that 30 equals to 4 times x plus h. We divided this equation by 2 and found out that 30 over 2 is 15. and 4 over 2 is 2. So in conclusion, we found out that 15 equals to 2 times x plus h. Then we divided this equation by 2, and finally we found out that x plus h equals to 15 over 2. Here, x plus h equals to 15 over 2. What is the length of this line segment UN? UN equals to UO plus ON. That is to say, UN equals to UO, that is x, that is the radius of the biggest circle, plus ON, that is h. So in total, UN equals to x plus h. So can I feel that UN equals to x plus h from one side, but from the other side, we have already found out that UN equals to 2b. Here again, we found out that UN equals to 2b here. So can I tell that UN equals to 2b, and from those two equations, UN equals to x plus h and UN equals to 2b, we derive that x plus h equals to 2b, but we have already found out that x plus h it is also equals to 15 over 2, so we can write here that x plus h equals to 15 over 2, and from this equation 15 over 2 equals to x plus h equals to 2b, we will derive that 15 over 2 equals to 2b. So 15 over 2 equals to 2b, we divided this equation by 2, and finally found out that b equals to 15 over 2 over 2, that is 15 over 4. Here b, the radius of this circle b, equals to 15 over 4 units in its length, and we have already found out that a equals to 2, and therefore the ratio b over a is b, that is 15 over 4, over a, that is 2. 15 over 4 over 2 is 15 over 8. So in conclusion, we found out that the ratio b over a equals to either 15 over 8, or in terms of numbers, it is equals to 1.875. Okay? The ratio between the radius of this circle, that is b, to the radius of this circle, that is a, equals to either 15 over 8, or in terms of numbers, it is equals to 1.875 without units. Okay, thank you very much.